What's up, guys? This is problem 41 of Neetcode 150. Add two numbers. Alright, so let's read the problem together. You are given two non-empty linked lists, L1, L2. So this is great. We already know that they are not going to be empty. So this is an edge case that we can rule out. Let's continue. Each represents a non-negative integer. So this is another cool information. So they already give us two gifts here. The digits are sorted in reverse order. Okay. All right. So number 1, 2, 3 is going to be represented as 3, 2, and 1. This is good if we have one of the two numbers or one of the two lists that is longer than the other one, because basically the unities will be always as the first will be always placed at the first entry of the node. Okay, so this is going to be good for us. Otherwise, we will have to reverse the list link. Each of the nodes contains a single digit. You may assume the two numbers do not contain any leading zero. Okay, except the number 0 itself. Okay, we have to return the sum. All right, and now I think the example 1 is pretty straightforward, right? We have 1, 2, and 3, and we have 4, 5, and 6. So if we had 1 and 4 together, we have 5. If we had 2 and 5 together, we have 7. And if we have 3 and 6 together, we have 9. Okay. I think there's no problem up to here. Example 2 is it shows a hedge case that we are gonna have to handle. So what if basically adding the two values gives something greater than 9? Okay, this is like in elementary school when you were doing our additions. We have to take into account and keep track of for example, let's just go ahead and do an example. It's going to be clearer. So let me use this. So what if we have like 478, okay, plus few hundred 86. All right, so when we do 8 and 6, we have 14, right? But remember what we used to do in elementary school, we'll write the 4 here, and now we write or rest or carry, however you want to call it. So the rest is here. It's a 1 because it represents 10. And now we're going to add our 1 plus the 7 plus the 8, which is going to be 16. So we are going to add 6 and a 1 here. And this is giving us 7, right? So we are going to have to keep track of this. This is the reason that you see that 9 and 9 results into 8 and 1. So I think I don't need to explain this any further, and we can actually go ahead and write the code. So let's just think of what we will have to do to basically render the result. The result is a linked list. We are gonna have to keep track of a list node that that points to the start of the result linked list. Okay, so we are gonna have to create basically I'm gonna add this some list. Okay, and this is basically just gonna be equal to a list node, and we also want to have what I like to call the runner, which is basically the pointer that will go through every single node in the linked list. So let's call it the runner, and let's set it equal to basically the linked list for now. Okay, and now we're gonna have to create a while loop. Basically, while there is a value in the node of the first number or the second number, because this is another case I didn't spoke about. But what if we have like instead of 286, it was 1286? Okay. Well, we know that the linked list will be given like this, so in reverse order. All right. So this makes it so easy because we don't actually have to reverse the list to have a correct addition. But the sole problem is that if here, for example, instead of a 2, we had an 8, well, basically we'll have a carry here. But there is actually no number here. Okay. So we will have to take this into account while creating the algorithm. But let's go ahead and just loop until both basically L1 and L2, so our two numbers, are empty. All right, and after this, we are basically gonna set our v1 to the value of I said vi. Let's just call it v1 for the first value, and this is going to be equal to the value of the list 1. And also, as I showed in the example, we have to take into account the case where we no longer have a value. So we are going to do this with the if statement. So if there is something at L1, otherwise we are going to just give a default value of 0. And we're going to do this for the v2 as well. So we're going to set the L2 to its value if there is a value. Otherwise, we want to set that to 0. Okay. And actually, I have to create the, let's call it the rest. Let's set for the first round, there's a rest of 0. And the rest is basically the units I added here at the top. So let's use another color to make it clear. So this is a rest. This is another rest, right? So this is what I'm referring to when I say the rest. All right. So after defining our v1 and our v2, let's just call that the addition, or let's say the result. Let's call it result. So this result is basically v1 plus v2 plus our rest. Okay. But now we actually have to define what the rest is, right? Because this here result, the result here might actually be like 15 or 16 or 14. So we are gonna have to take the integer division of that that result, and this is gonna give us basically the result, or the rest, right? So the rest is gonna be equal to that result with the integer division of 10. All right. And once this is done, we actually have to, let's say we have 15. We want that the value that we add, or the result that we add in the list node, we want this to be 5, right? So we are actually going to do this by saying that the result is equal to the result with 10. So if we have 15 here, this what you wrote here is basically saying take the rest of that divided by or the rest with 10, and in our case it's going to be 5. So this is how we actually gonna reach that 5. And okay, after this we have our 5. So what we're gonna say is basically we're gonna set the next value of that that linked node, that linked list, sorry. So it's going to be runner.next, right? Because it is the runner that goes through all the values and that will set basically the node at this point to be the result that we have, which is a 5 if our value is or if our results is initially 15. Okay, and after this, what is left to do? We have to basically make sure the runner is moving forward. So we are going to say runner is equal to runner.next. Okay. And also we have to make sure that the list one's pointer and the list two's pointers are both moving forward if there is actually a value forward. So L2, let's first start with L1. So L1 is going to be basically L1.next. If there is a L1, right? Because there might not be any value, we might have reached the end already. So otherwise we want to make sure that it is set to none, which will trigger a 0 here in our initial if statements. And we're going to do the same thing for L2. So L2 is going to be equal to L2.next if there is L2, and otherwise we want to set that to none. Okay. So that's pretty much the nth algorithm. Once we actually once we break that while loop, we are actually gonna have a list now that is complete. But actually, before we return the next value of our sum list, I just forgot something here. So we are actually gonna have to while loop, not while there is a L1 and a L2, but basically when until one of them is still has a value, or there actually is a rest, right? Because if there's a rest and there is no value on both, we still have to add a rest, whatever it is. So after this, we are good to go, and we can finally return basically our sum list. That's next. All right. So let's test that out. And there you go. All right. So I hope you learned from this video, and I hope to see you in the next one.